Hi, very good morning all. Welcome to the day two technical session of advanced performance engineering. Very good morning all of you and greetings. Today, as part of the performance engineer technical demo session, right, we are going to talk about common performance problems. And when we are talking about common performance problems, right, it refers to all the problems that we see during the load test execution, be it any environment, be it any technology, Java, .NET, anything. The problems that we see from web layer, app layer, database layer, problems that are happening from different areas of your architecture, all these things we are going to talk. And in specific to that, today I would like to highlight some of the Java application performance problems that are most commonly seen by everyone of us in day-to-day assignments. Okay. And in Java application performance degradations and problems, when we are testing any Java application, there is something called JVM where you can have one to many instances of JVM in multiple application servers you have. It can be anything, IBM, Oracle, JVM, and multiple application servers like Apache Tomcat. You can see WebLogic, WebSphere, different application servers, right? When I say JVM has different monitoring levels. Okay, what is the type of monitoring that we have to do? What are the areas that you need to look at? And finally, we are going to talk about the analysis and troubleshooting part. Okay, so coming to the common performance problems, right? If you have attended my any of the previous sessions, we always used to talk about the common performance problems. I would say they're not completely common from all the different applications that we are testing. They are sometimes they are specific to the type of technology that you're using. Okay, so uh, if you have attended any of my previous sessions, there is something called 80-20 rule. Okay, so you always need to remember this point. 80-20 rule is nothing but 80% of the performance bottlenecks they do happen just because of 20% of inefficient code. Okay. So if you take any performance testing assignment, if you take the development team, they skip something called code profiling. Okay. When you don't code profiling and code optimization from the very early stages of development life cycle, as soon as a service is ready, as soon as a module is ready, as soon as a page is developed, right? When this code profiling is skipped from the development team, it is already skipped from many of the organizations and many of the teams. It will become the responsibility of the performance engineers to profile the code. Okay, I'll tell you why. If you don't profile the code, 80% of the bottlenecks they exist and they remain open, even if you're doing continuous testing on multiple releases and working in agile sprint methodologies. Okay, so when you ask the developers to do something called code profiler, most of the teams they feel this profiling thing as an extra piece of work and they skip it. If you go back and see all your projects, whosoever joined today, the question to all of you is how many of the applications are really doing code profiling? So I'll tell you the importance of code profiling and what is the use of doing code profiling. It is always difficult to implement a fix on every single function, method, or a class or an object that is creating a performance degradation, because a particular fix can also bring some new performance problems on the other existing functionalities which are already working fine. So some sort of regression, some sort of understanding here is very crucial to identify what are all the areas that has to be fixed, what are all the areas are that has to be still remain open for the few upcoming releases. Just because to avoid new bottlenecks, we have to do code profiling and we have to work on all the different aspects. And also coming to the other point, when I am referring to common performance testing problems, right? Whenever someone is doing performance testing, most of the problems you get from client side and server side. You may get some performance problems from the network side because of network congestion. Okay, you might get some problems because of latency, and again under latency you are going to have serialization delay, propagation delay, and you're going to have jitter. Jitter is nothing but the latency variance that you're seeing, right? So all these things can happen. When I say client side, server side, when we are specifically dealing with server side, right? Especially with the application server, we are main worried about the memory related areas, out of memory errors, memory leaks, deadlocks, resource conditions, high resource utilizations, connection drops. Lot of things can be seen in different levels. So if you consider our point, 15 to 20% of the bottlenecks they happen from web server, 25 to 30% of the problems they happen from the application server, and all other remaining 50% of the bottlenecks they happen from database server. For example, whenever you send a request, is it one hit or multiple hits? Anyone?
Multiple requests.
Right? So if you take any simple application, simple web application, I would like to give you this particular thing. Just give me a minute. So you should have this level of understanding. If you see this diagram, okay, simple get customer details, okay. When you send a request here, this is one hit on the web server, this is two hit on the web server. I mean, second hit, you have two hits on the web server, two hits on the application server, and two hits on the database server. You can clearly see that when you send a request, okay, it is sending two HTTP requests onto the web server, one for the core page, which is a Java server page, JSP, and one for the image itself. Okay, these are two HTTP requests triggered on the web server. And if you take application server, there will be two methods that are being executed, invoked on the application server. When it comes to the database server, there will be two SQL queries that will be running on it, and it is going to bring the response. So from everywhere, you are going to get some sort of response when HTTP request is executed here on the web server, when a method is executed on the application server, and when a SQL query is executed on the database server. The total time that you have here is called the round trip time. Okay. You also, whenever you get the NFRs, you also have a target estimation where you are sending a request, the overall target would be explained like this. The overall target of the application can be 3 seconds, where the time it has to spend from web to app, DB to app or app to DB should be less than 1 second, or app to web server, web to app server should be less than 1 second. The remaining 1 second should spend on all the other processing parameters. It could be touching some API servers, file servers, or whatever it is. The complete processing, executing, logic implementation has to happen within that 1 second. So this is called target estimation. So when I say this particular, when I explain this particular scenario, when I'm referring to common performance problems, you always get a problem with a database, which means that pages which has to load data from backend database. When I say backend database, every request when you're sending to the database, each request has to send to the database and it has to pull a data set. That data set can be small, or it can be moderate, or it can be in big sizes. Even for the request that you are sending, right, request will have some message, and that message will have some size. Okay, for example, 50 KB example I'm saying, we have some standard parameters. Each request that you're sending will have some message in it, and each message would be having a size for that. So every request that is actually creating some activity on the web app DB servers would have some size, and that size is something which will help you to create the size of web server, application server, and database server. Okay, and Mayank will talk about the questions in the last, because we have 15 sessions. We have 15 minutes in the last. Okay, we'll keep this questions open. You can make a note of your question. We'll address that. Okay, when I say pages which load data from a backend database, there can be numerous reasons why your application can be slow, why your system can be slow. Okay, why your server can be slow? So there can be wide number of reasons that can create a performance problems when loading the data from a database. Example, yesterday someone asked me, how do you troubleshoot? How do you identify? How do you conclude this is a complete database problem? So we need to look at some tens of metrics, sometimes hundreds of metrics. We need to correlate them and interpret them, compare them with other test execution runs and as well as with other metrics to see what value is increasing with what. If you take a specific database, they can have inefficient or unnecessary table locking. If you have a bad cache mechanism implemented, which is also called improper caching, and you already know there are long running queries, which are high load SQL statements, badly performed queries. Okay, you have IO peak periods, you have high resource utilizations, and lack of badly used indexing, which is also called missing indexes. We'll not talk about all the basics now because we have extensive database performance engineering session in this program where we are teaching everything there, right from the basics, what is DML, what is DDL, what is select, everything we are going to teach that. So these things are not, they cannot be easily identified, okay? So when I say the common performance problems, my first suspect would be always primarily the database. Okay, then I come back to application server to see how the memory utilization is happening, how the resource contention is happening, what is the reason for deadlock. I look at the stack traces, I look at the connection limit, I look at the thread pool, connection pools, lot of other parameters. And coming to the client side, recently many of the assignments, they are not being evaluated with something called client-side performance testing. So when I say client-side performance testing, all the page assets and other assets that you are seeing from be it static, be it dynamic, if they are available in cache, not available in cache. So if the pages are not optimized, if the page assets from the client side are not optimized, you will see a performance degradations. According to the recent surveys, that has been happened by multiple vendors on the client side performance testing, 50 to 80% of the bottlenecks degradations are directly from the client side. That is why the reason in parallel with development, we are doing something called early performance testing and client side performance testing to eliminate the bottlenecks at the very early stages of your application development so that you don't see high response times, high resource utilizations when you take that application to end-to-end performance testing. So when you're testing with 10,000 users, 15,000 users for 8 as well as you, half of the performance degradations will be optimized at the very early stages. If you're doing early performance testing, testing a web service as soon as it is ready, baselining, benchmarking, doing client-side performance testing. So the number of images, assets on a page will have a significant impact on the response times. If you take Amazon, Flipkart, any e-commerce site, it has to bring thousands of images of all the products. Okay, each image that you're bringing onto the screen can mean one HTTP request. Example, if you're accessing searching a product, it is bringing 15 images on that product. More number of images can mean more HTTP requests, with each one requiring a round trip time to the server. Okay, so for that reason, in client-side performance testing, what we do is we compress the images properly, we take care of the size of each image, and we optimize the performance. That is one example on the page assets. If you have JavaScript calls, they're getting minified. For example, if you have a JavaScript call which is taking so much of time, there are minifier. If you take minifier, if you click on problem, if you collect the problematic JavaScript and CSS, if you go to minify, like the way you do heap dump analysis in heap hero and thread dump analysis in fast thread, GC log analysis in GCEZ, you can take the problematic time taking JS call or CSS, you can paste it over here, and when you click on minify, this minifier is going to optimize that time taking JavaScript call and CSS. Okay, so minifier basically what it is going to do is it is going to remove all the extra spaces, duplicate lines of code, everything that you don't need, and it is going to give you the optimized JS call and CSS call. Minifier is going to do a lot other things we are not discussing in detail here. We are going to take that in client-side performance testing. And the other thing is spaghetti code, which is also called inefficient code. When I say inefficient code, right, this is one of the main problem for all the performance problems. Okay, custom code, when someone is developing something on a page, on a module, it is developed in isolation. When I'm saying isolation, that particular code is handled with little or no testing is performed. Okay, which is so called unit testing or integration testing. You're writing some code, when you run it, you're getting the output. That is what a developer is going to check. But when it comes to the performance aspects, that particular code snippet, how much time it is taking during the compilation, how much time it is taking during the interpretation, how much time it is taking in the JIT compilation phase, or how much time it is taking in GC, and how much time, overall time it is taking to give you the output. Okay, it is at the unit level. Integration, again, this code is integrated with some other component. It has to work collaboratively to get all those numbers. When it is taken to the system level, it has to do parallel computing with all other components. It has to process your code when you have concurrent calls, concurrent requests. In that areas, we see the problems, we see the degradations on code optimization. I mean, if the code is not developed in isolation with no testing is done, even some of the problems are completely missed in functional testing, and they'll become apparent when you do load testing. Only when you do load testing, you're going to see all the problems. One problem of a very badly implemented code is badly implemented thread safety. When I say badly implemented thread safety, for that, for all of this, to understand every performance engineer, I am again telling it to you, a good performance engineer should be a good developer first. Okay, so if you want to understand badly implemented thread safety, it is going to create resource contention, it is going to create deadlocks, and it can cause all the functions to lock, and it is going to give you an error message. I am not saying that these issues can be easily solved. These issues can be solved by taking multiple thread dumps, multiple heap dumps. Sometimes you need to take the help of GC logs. Sometimes you need to look at the other servers that are already working in parallel with your application servers like database to rightly troubleshoot the problem. Okay. And also coming to the other performance problems, the VMs that you're working, when your application is hosted in some X data center, okay, your VMs can also be a problem. Virtualized environment configuration, right? Virtualization has so many benefits. It can also increase the complexity of identifying some performance problems. In VMs, you may have dynamic reallocation of resources. When you have this dynamic reallocation, right, many of the problems are hidden. Okay, you may have resource contention across the VMs that you have. It's not always the problem with the script that you're running, with the environment that you're testing, the application you're testing. It could be also a problem with VMs. So for that VMs, you can also monitor all the data centers of the VMs with dynamic reallocation. They have some set of metrics, and you can easily identify the performance problems. Okay, when I say environment configuration, you have to validate solution designs, you have to know the configurations. If you have frequent problems that are coming up on an application after sending it to live, it can be because of load balancing setup, it can be because of firewall configuration. So sometimes, right, you do rigorous testing on a staging environment, on a dedicated performance testing environment, and you give a go ahead on to your application to send it to live, right? When you're sending this to live, then you start see problems coming up because you're not permitted to do testing on production environments. Sometimes, most of the times it is not possible because you're already testing good in pre-production environment that is a representative of live, or it could be 50% of live, or it could be 1/16, 1/4 size of your live, validating this configuration changes. So each time when you're sending something, when you're testing something very aggressively, you have to know all the configurations. Firewall implementation, firewall rules that are set, load balancing algorithms, okay, the role of DNS, the role of CDN, okay. If you look at many of the outages, I have referred to this example yesterday. Instagram outage or WhatsApp outage or Facebook outage, they are because of DNS failures. If you go back, look at your environment today, no DNS or CDN is implemented in performance testing environment. So is it making any significant impact on the performance? Yes, it could be. Because DNS are like the phone book of all the domains. By just taking your IP address, it is going to do some other process activities. It is going to look for your domain very quickly, and it is going to give you the content to the user as quickly as possible. In case of DNS, all the 404 errors can be because of DNS failures. Okay, you can also look at the CDN, DNS. Each one of them has got a big list of metrics where you have to monitor in the prod. Okay, SREs do that. You have to monitor that in the prod. In case of any other failures, I'll tell you how to troubleshoot and what you have to do here. Okay, poorly written code can lead to many problems where the entire application can go down. It can be because of inefficient algorithms. Can we identify inefficient algorithms? We cannot. You have to do code profiling. When you do code profiling, it is going to tell you which method, which problem, which statement, which part of your code, which class, which object is consuming highest amount of memory. Example, functions occupying the most amount of memory. Types of functions with most of the memory that they are getting allocated, right? Object allocation, object lifetime, call tree, all these things are taken into consideration when you identify something like a poorly written code. Okay, inefficient algorithms, if you have poorly written code, if you have badly implemented design of your application, bad software architecture, so everything can create a memory leak. It can create an application deadlock. If you're still using older versions of the softwares or integrated legacy systems to the update to the latest version of your application or product, it can also completely drag the performance of your application down. Okay, and also I said the databases, right? When I say the database, right, so most of the main challenge here is in the databases. Even if it is a testing environment, even if it is a dedicated performance testing environment, no one of you will get access. If you're working in a JPMC, Bank of America, Morgan Stanley, Citi, Lloyds Bank, SunTrust, all the BFSA, Interpol, stock markets, capital markets, investments, trading applications, they don't want to reveal the configurations of the data that you want to see, even if it is on test environment. Okay, so when you don't have access to the database, you'll not be able to understand what exactly is the problem inside the database. You, to some extent, I would agree that you can collect a big list of metrics and you can see various parameters. Okay, like CPU utilization, memory utilizations, cache miss, cache hit, hard passing, soft passing. Then you have different metrics. I mean, from the database side, you have a lot of metrics. Again, for example, coming to the processor, you can monitor percentage processor time, percentage privilege time, percentage user time. So you can look at all these things, but the problem here is if you want to understand the problematic virus which has missing indexes, you should have access to the database. Missing indexes can completely slow down the performance of your SQL queries. Sometimes they can drag the entire site down. So for that, you have to use some utilities like SQL Profiler, SQL Segment Advisor, You need to have different utilities. You have to run ADDM, automatic database diagnostic monitor, for example, on Oracle database. You have to take multiple AWR reports. You need to take active session history report to see what are the problems inside the database. Okay, and most of us, what we don't understand is uh, growth in data. So if you don't see the data, right, the percentage of amount of users increasing, the number of hits increasing, requests per minute. If you take Twitter or if you take Shopify, it is going to handle 50,000 requests per minute, per minute, okay, per minute or per second, giving a response time of 45 milliseconds. It is running on Ruby on Rails. Okay, Twitter has moved from Ruby on Rails to Scala, whereas Shopify is still working on Ruby on Rails framework, which is doing 50,000 requests per minute in 45 milliseconds of response time. Okay, when I'm referring to throughput, it is number of requests per minute, number of HTTP requests processed on data web server, number of methods executed on application server, number of SQL queries or stored procedures executed on database server, number of transactions passed per second, TPS. This is all throughput. Okay, if you see data systems, if you're doing some batch ingestion, if you do some batch jobs testing, data systems basically they tend, when they are dealing with large amounts of data, they tend to degrade over time. So every time when you see growth in data, you need to develop a plan. You need to monitor in all aspects to see what percentage of data is growing on your web application. Okay, when you see more amount of traffic coming onto your website within a very short time, the first step is to decide who is accountable for this data growth, what type of users, from which location, what are they doing, what activity is being performed. And if you get all this data right, if you have a plan like that, you can initially plan the storage needs. You can increase your hardware software configurations of all the web app type servers that you have in your environment. You need to look at all the possible options from databases to cache implementations, and you have to decide storage accordingly. So I'm talking about the traffic spikes here. If you're a YouTube blogger, if you have a food channel, if you're a travel blogger, when you upload a video, any user, any customer, from the business point of view, end of the day, when it is business, we generally think of increased traffic. When I see increased traffic is a good thing. When you experience, the problem here is when you experience a major traffic spikes, you are going to get so much of other problems. Okay, some systems can go down, some systems can stop working, some services will automatically stop working with huge volumes of data that is already there on the systems. More number of users are coming, more concurrent calls are happening, more number of SQL queries are being executed with the undersized configuration of hardware that you have on your database server. Lot of things that you see. Okay, and coming to the most commonly performed mistake by any of the performance engineer, when the customer doesn't know anything, this is which is most commonly done by many of the teams. Later they realize, but by the time someone realizes it, right, the time, the budget, the project will go to, it get moved to some other company. The business of your company will move out, and the opportunities that you get will be less. So poor load, assigning a wrong workload, doing a load testing with poor load distribution you will not only see slow response times. When you're doing wrong workload assigning of all the tasks in your application, you will see high response times. It is not actually high response times. You have to understand it is not the way the users are actually accessing the application in prod. Not out of 100 people, 90 people will not click on can't access my account in Gmail. That is not a concurrent operation. The priority of the activity, the priority of that particular task, functionality in that application is very, very less, which is 1% out of total number of users you have on your application. How many of the users are actually trying to enable step 2 verification on daily basis when you open your Gmail? So poor load distribution, if you're doing this, everything is, you're wasting time, you're wasting your efforts, everything will go wrong. incorrectly assigning new visitors, users to some wrong functionalities, doing some multiple rounds of testing, it will give you inaccurate results and it will waste your time. When you do this, the problems will not stop here. People will start working in the wrong places to implement the performance fix, which will give you the new performance problems. And it is going to take some years of time to realize that you are in the wrong place and you have assigned the wrong workload. The same thing applies to selecting a wrong tool. If your tool is not actually capturing, recording everything that you want, then it's a gone case. If you're incorrectly assigning workload to the functionalities in your application, too many people will be on the same server. They're going to experience problems. And the overall system, you will get so many problems, right? So coming to the configurations also, there's the last bottleneck, I would say. Coming to the configurations, every time your performance testing environment is set up right from the scratch, a performance engineer should take part in that to understand how systems can be properly tuned in case when you see problems. Everyone, when they're doing performance testing, they go with default configurations to make the things easy, or to get components up and running in the environment, you go with default configurations. They're not right, they're not appropriate all the time for your web application, like the way you have in live production environment. For here, you have to check every setting. It has to be checked. Example, review thread counts, check the amount of memory given as heap for all the application servers. What are the permissions you have? So you have to check all the configuration parameters that are placed on your web application when you're testing in pre-prod or QA environment, dedicated performance testing environment. DNS queries, I told you, right? DNS configurations, DNS queries make up the majority of the traffic. That's the reason DNS issue can cause so much trouble. And sometimes in case of DNS failures, it will prevent visitors from accessing the website. And it is going to result 404, HTTP 404 is incorrect pathways. Network connectivity can be a problem, right? Firewall efficiency, they are very, very crucial for any web application access and productivity. So you have to monitor DNS, you have to know the configurations on DNS, how they are implemented. You have to know the configuration of firewalls. Simple thing, wf.msc. If you open this one, you have inbound rules and outbound rules. If you want to allow someone to access my server that is installed on my laptop, you have to create an inbound rule, create a new rule. You have to run a program here. Oh, sorry, not a program. You have to create a port open. Okay, then you have to apply this one. You open some port 8080 something. Okay, you click on next. Allow this connection, or you can allow this connection if it is secure. You can also block this connection. When you click on next, you can also apply this rule to which users it can be applied. So domain applies when a computer is connected to its corporate domain. Private, it is going to get connected to a private network location such as home, working from home, or workplace, or it could be a public domain. Give me a minute, please. So I'm sorry. So you can say that domain, private, public. You can public when you select public, right? It's going to access. It's going to give access to anyone. Okay. If you go back, did I give? No, I did not give anything here. So when you click on a next, it's going to ask. Let's say IS or something. Access. I'm just doing it for your understanding. So you can see the complete things here, right? Apache common daemon services is running because you have created this one. So you have to check all these options. Okay. These are just a few ways to troubleshoot these types of performance problems, which we commonly don't see. Okay, which we don't care about. Just because we don't have access, we have restricted access, we have limited connectivity to all these areas. Okay, So, and also troublesome third-party services, right? When I say troublesome third-party services, I am talking about an example IRCTC where you when during login time, a LIC ad is displayed. If that ad is not displayed on your application, it's not always the problem with the application code, application or the database. It could be problem with the troublesome third party where you have integrated your application with the ad server, LIC ad server. If you are relying on third party services, basically slowdowns are going to happen. These slowdowns are out of your control. When you have such slowdowns with any of the troublesome third-party services, you should not touch, you must not touch the source code or the other areas which are already working fine in your system. You have to identify where the problem is from. Okay, your page is loaded, your response has been it has been there on the screen. Page load time is already done. All the pages assets are loaded, but our application is still waiting for a page from someone else ad server, which did not load. If users are experiencing problem like that, the first step is you have to identify that problem is on your side or is it from the third party. Okay, so if it is a problem from the third party, you have to tell them to make some design changes to protect your site from some of the effects that are happening just because of third-party services like this. So these are all some of the common problems, and the last one could be the problems from the network and load balancers. You always have metrics for this one. When I say load balancers, right? Simple examples I'll tell you. Load balancers, each load balancing algorithm would require, they perform differently with the type of load balancing algorithm that you select. Least weight connections, round robin, weighted round robin, weighted least connections. By default, you're going to use round robin. Okay. And network, when it comes to network, there will be so much of network delay. You're going to have network delay segment graph. Anyone know this graph in LoadRunner? Network delay graph. Network delay graph, what is it saying in LoadRunner? It is going to give you the delay time between the source and destination. Okay, network segment delay graph. There is another graph like that, a network segment, I remember. So it is going to give you the delay at each node between the source and destination servers. Between the source and destination, you can have multiple nodes. The delay between every node, you can get the breakup at network segment delay graph. You know what is time to first buffer? I'm not talking about time to first byte. TTFB is different. TTFB is when you send the request, it is the server's first reaction. The first byte that you are getting it from the server and you see the response on the web browser. Okay, but whereas TTFB is a graph that is available in LoadRunner where you have server time and network time, two metrics. When you have high response time, when you look at time to first buffer graph, you can easily identify whether the response time, the time that it is taking by the application, which is so-called high response time, is it a problem from the server or from the network? Server time is 6 seconds, network time is 2 seconds. This graph is going to tell you it is problem from the server, not from the network. If network time is 7 seconds, server time is 1.5 seconds, then we can easily identify it is the problem from the network. Okay, so all these things are common performance problems that we get in many of the performance testing assignments. It could be, it could be many other performance, many problems from many systems which are developed with multiple technologies. All the problems you see with all the different languages that are developed. That's not the most commonly most seen performance problems across Java applications, .NET applications, SQL applications, Citric applications, anything. But when I'm referring to Java, This is something very, very important because most of the questions are frequently asked in the interviews. Java, right, Java.NET are the most popular technologies for the application development. Comparatively, Java is very popular. Tens of thousands, millions of developers uh, are using them daily. Java, if you take Java, right, it has been evolved over decades, and there has been so many frameworks. There has been middleware, data access technologies, protocols built on Java. If you compare to C, C++, and other languages, where memory management is manually done by the programmers, which means the programmer has to create an object. As soon as the task of that program is completed, the programmer, he or she has to destroy the object to reclaim the memory in the languages like C, C++. But Java, right? Java is self-regulating, which means it has come up with something called automatic memory management, which is a powerful utility called garbage collection, which is going to manage the memory, which is going to free up the memory on its own automatically. Whatever the performance problem that you see in Java-based applications, whenever you have a problem that is going to happen, if it is impacting the business, okay, you have to look at some various places, especially from the JVM monitoring, especially uh, from the code side, from the middleware, inspecting the code, all these things. There are some popular problems, uh, some performance problems in Java, performance test engineers and Java developers and administrators encounter. And there are few things that we can recommend, and it depends again on the situation. Okay. Now, most of the problems we always get from memory. Okay, when I say memory, I'm going back to the same point, inefficient code, which is also called spaghetti code. So most of the problems that you see are uh, out of memory errors, right? Whenever I say out of memory errors, they happen from JVM. Okay, whenever I say out of memory errors, they do happen from JVM, when you have high object creation rate, when GC is not able to do its job as expected, when you have a problematic objects, when you have premature promotion of all the objects, when you have even for a small amount of code, the more number of objects getting created, each one having very high size, each object is taking so much amount of memory. Very soon it get filled up with objects, and at certain point the GC will not be able to do the reclamation of memory as expected. And when memory is completely filled with objects, there will be no space left for the new objects that are coming in. It cannot accommodate, and it will show you out of memory. It will throw an out of memory exception. These out of memory exception can happen from the young generation, old generation, metaspace. You can have different out of memory exceptions depending upon the runtime data area. You have so many runtime data areas, different runtime data areas in JVM, Java JVM. So any area of any memory area in the runtime data area is full, you're going to get java.lang out of memory exception error. Okay, so even you see different problems just because of excessive garbage collection. When I say excessive garbage collection, when the GC is going to happen much more frequently, if more number of times the GC is going to happen, it means that the objects are not getting deleted from the heap. Okay, so I am going to tell you one by one. And coming to the third bottleneck from the Java performance applications is improper caching. If you don't do this one, you will see lot many bottlenecks. These are from something like from the memory. I'm going to explain you each one. Do not worry. Coming to the threads, right? You're going to see thread. You're going to take multiple thread dumps. You're going to look at the stack traces. You're going to look at the waiting threads, blocked threads, threads which are continuously running, hung threads. All these threads, why you're looking at? Because you're going to see resource contention. You're going to get deadlocks. You're going to get gridlocks. you're going to get, you have request execution, wait time, excessive use of thread synchronization. All these things are going to create deadlocks. In order to identify the deadlocks, in order to identify resource contentions, in order to identify high response times, if the application server is getting crashed, is becoming unresponsive. If you see high resource utilizations on the application server, it's high time to take thread dumps. And this is where you're going to understand what are the different threads that are creating the problem, are the reason for the deadlock, all these things. Okay, so when I say threads, right, it's going to talk about deadlocks. When I say deadlocks, you're also seeing resource contention. I'll not go much into that, okay, because this is a separate session in thread dump analysis where we are spending some 4 to 5 sessions. Same applies to the memory part, heap dump analysis where we are taking 4 sessions, okay. And coming to the other problems, when you have these problems, you can also see the problems with the databases. When I say databases, simple thing, anyone of you tell me one simple database bottleneck when you're doing load testing?
Missing indexes.
And
Query optimization has not been done properly.
have you ever encountered something like this? No one? Let me see if I'm able to connect. Because I want to show you one specific thing. You're able to see my screen, right? I connected to one.
Yes.
This MySQL server, okay? You can see the client connections. You can see the connection limit here. Do you see this one? You're able to see that, right? Threads connected, threads running, threads created. Yes, no?
Yes.
Okay. So running out of connections is like the application is using all your connections. And when they say you cannot increase the connection limit just to increase the availability and scalability, you cannot do that. That's actually the decision has to be taken very wisely, because simply increasing the connection pool, simply increasing the thread pool, simply increasing the connection pool when you are getting some errors, it's not going to improve the performance by 0.001%, not going to improve the response times, but it is going to increase your throughput. Okay, when you're increasing something, when you're doing scaling, when you're doing increase the connection limits, when you're increasing the thread pools, application pools, you also need to check if the response times are within the acceptable limits. When you don't have that, why are you increasing all these things unnecessarily is the primary question, right? So if you can see here, simple dashboard, you can see what is the rate at which you can see other things are continuously happening. For example, you can see selects per second, you can see inserts per second, you can see creates per second. When a test is running, right, you can see all these things when you have access. Client connections, you can see the limit. See, when the connection limit is completely used, you will see this running out of database connections. Okay, this is one thing I would like to show you. And performance reports also, it's very easy. It's not like taking AWR ESH reports. High load SQL statements, if you click on statement analysis, it is automatically queries the performance, and it is going to each query, it is going to tell you how many full table scans it has, how many times it has executed, how many errors you got, what is the time, what is the rows sent, average rows, total rows. All these things you can get. See, I mean, I'm saying that memory used by the user, it has some automatic wiring methodology, which can, when you click on this, it's going to, if you want to know the full table scans, as soon as you click on this one, it's going to give you the informations like this. List, it is going to list all the statements that have performed a full table scan. Okay, so this is one thing. Someone is asking a question. I'm not regular problem in our systems. Okay, tables, deadlocks, inserts, latency. Okay, so this is one thing I would like to highlight. And coming to running out of DB connections, they can happen just because of slow DB calls. Slow DB calls is different from high load SQL statements. Okay, slow DB calls can be because of also the connection problems, connection drops, connection leaks. Okay, when I say connection leaks, no one are going to talk about connection leaks. You know what is a connection leak? Okay, we'll talk about that later. We are running out of time. So finally, from the application code, this is a very big one. Okay, when I come here, we have to talk a lot about Java code level issues. All the code level errors will impact the performance of your application. Okay, and you can also get app server bottlenecks here. Java application server bottlenecks. All the bottlenecks that you see here are just because of poorly developed code. And the last one could be from the infrastructure. Infrastructure level monitoring is something which you have to take care. Infrastructure, when I say infrastructure, all the server related problems. I'm not talking specific to one application server. I'm talking about web server, app server, and database server related problems. And now someone has already answered this question. Network latency and connectivity problems. Okay, so when I am talking about out of memory errors, if I talk about one by one out of memory errors, this is the most commonly seen error, which is called java.lang. Out of memory error. This is the exception you see. Java.lang. Out of memory error. Okay, so this is an indication that your application is trying to add more data to the memory, but there is no additional room for it. Out of memory error will directly stop the users from everything. It is going to result in failures. The application server cannot, or the application cannot recover from this out of memory error. And each time you see this, right, when a question is asked like this, what do you do when you see an out of memory error? I'm going to increase my heap size. You're right. But increasing the heap size is optimizing the performance of your application. Is it giving you the acceptable response times? Is it giving you the acceptable resource utilizations? No. If you're getting an out of memory error when you're running a test for 2 hours, if you're getting an out of memory error in first 30 minutes, if you're increasing the heap size from 4 GB to 8 GB, it is going to postpone your out of memory error. Instead of getting your out of memory error in the first 30 minutes, you will be getting it in 1 hour or 1 hour 50 minutes, but you cannot avoid this error. There can be so many reasons why you are getting out of memory error. Okay, because if you have undersized heap memory in the JVM, if you have undersized young generation, if you have undersized older generation, okay, if you have problematic objects in the hidden space, if the survivor spaces objects are, if they are not surviving garbage collection, So there could be different problems. So if you have an out of memory error, you have to take multiple heap dumps, multiple thread dumps, and you have to identify which are the problematic objects, which objects are creating the problem. All these things you have to completely look into. Okay, JVM is configured to handle its normal load. When any of the node goes down, the other node will need to handle the additional workload. If you have a spike in incoming traffic, spike in application, what will happen? The load can be easily triggered and you will get a out of memory exception very soon. For that reason, you have to consider a load balanced server cluster where each of the JVM is configured to handle its normal load. Simple. One node goes down, the other node which is already up and running, it has to handle the additional workload. When the memory configured in the JVM is not sufficient to handle the increased workload, out of memory exception is what you see. And programming errors, when I say programming errors, all these things happen just because of programming errors, inefficient code. I don't directly make a blame statement on the development team, knowingly or unknowingly, when they are collaboratively working together. Depending upon the exercising that is going to happen on each and every layer of your infrastructure, things do happen. A memory leak in the application can be caused by a programming error because the Java garbage collector is not able to reclaim the memory. It's not able to delete the unreferenced, unreachable, and dead objects. All this terminology is same. If a code keeps adding memory to the heap, example, continuously growing hash table, you're going to get an out of memory error. So if you ask me what is the fix, either you have to increase the heap. One thing is that is a valid statement, but it is not going to improve the performance. Okay, you have to look at each and every individual memory areas that are available. For example, if you look at my DZone article here, 1 minute please. Okay, if you look at here, you also need to find out which area in young generation is filling fast. Any generation, for example, if Eden is getting filled with objects very quickly in young generation, okay, or survivor pages are getting filled up with objects very quickly, or if your older generation is undersized, or if your perm gen, which is also called metaspace from Java JDK 8 is undersized, you're going to get memory problems. You need to find out the excessive memory usage. To find that out, to find excessive memory usage, you have to take heap dumps from the JVM. You have to analyze the dump using a tool like Eclipse Memory Analyzer. Identify the objects which are taking so much amount of memory. Then you have to fix the code level issues that are causing memory leaks. Okay, and when you talk about excessive garbage collection, I told you, right, this can happen for a lot many things. I mean, again, code level problems. What you have to do for best performance, garbage collection should be taking a very small amount of less CPU time. When the GC is running, your CPU utilization should be less than 10%. If it is more than 20%, CPU time is mainly used on garbage collection. It means application has a significant memory-related performance problem that must be corrected. So you have to configure JVM's memory to a large, I mean, it has to be large to achieve the desired performance. So if you have bigger sizes of young generation, older generation, and metaspaces, right? If the memory area is so big, the GC will definitely, it is going to take a lot of time. If the memory areas are small, they're going to less amount of time. If you want to clean a room which is with full of garbage, if you want to clean a garbage tin, it takes less time. If you want to clean a truck which is full of garbage, it takes a 1 day. If you want to clean a tin, it's going to take minutes of time. Simple. So you have to track instances of GC, time taken for GC, percentage time spent in GC. These are all some of the important metrics. High GC pause times, you need to look for the high GC pause times. How many minor GCs, major GCs, full GCs happened. So all these things you have to look at. You also need to look at the threads which are taking CPU, and you have to drill down accordingly. Coming to the caching, right? Caching, you must be knowing it. It's a duplication of having everything in that, and it is going to read. I mean, it is for faster reading of data into memory, right? So suboptimal memory configurations for caching, I mean, default configurations can lead to more GC passes, more number of times the GC can pass, and it could affect application processing. So misconfiguration of caching will lead to so many problems. Example, objects are cached, which are stateful in nature. So when caching is not properly set, a recently used object could be mistakenly removed from the cache. Again, it is going to take room for a new object, resulting in cache miss. Okay, so implementation of cache, badly implementation of cache, improper caching is going to give you so many other problems. So for that, you have to monitor the cache size continuously, get alerted, monitor cache hit, cache miss ratios to track the success of caching process. And you also need to look at synchronization of distributed caching that is going to happen in multiple servers. All these things are possible in APM tools. You need to have complete access to that. When it comes to threads, deadlocks are going to happen, no doubt about it. So when I say deadlocks, right, this is a very big word. We're going to talk about that, deadlocks and resource contentions. To identify all these things, you have to take multiple thread dumps. The frequency of taking a thread dumps also matters a lot. Okay, databases, you have to constantly monitor. So, okay, coming to the threads, what you have to do from your side is monitor the status of threads in the JVM. You have to look at the count of threads that are running, blocked, and they are in deadlocked state. You can use Java performance monitoring tools, which will help you to detect blocked threads, deadlocks. You can identify the exact module and the line of code where the locking is happening with the help of stack traces, and that stack traces are available in thread dump analysis. Running out of database connections, I have already shown you. So you have to continuously monitor the connections to the database. For example, total connections, active connections. And when you track the connection pool metrics, how many of them are allocated, how many of them are freed, how many of them are closed, you can correlate all these things to get the visibility of the connection delays, waiting requests, to see what is the problem on the database. And coming to the database calls, right? Database calls, it's going to happen just because of slow queries. When developing an application, developers, what they do is they focus on getting the functionality right. They don't worry about the performance. Same thing applies to database queries. Whenever a SQL developer is writing a query, they are going to validate whether that query is returning the correct results. These queries, they're not designed optimally. I mean to say, you're getting the output. That query can also take 3 to 5 seconds there itself in the database. When you're achieving a response time of 3 seconds, when a single query of a particular transaction is taking directly 3.5 seconds from the database execution side, how can you achieve 3 seconds of acceptable response time when you're testing with 5,000 users or 10,000 users? So you have to look at the problematic queries from the database level itself. Okay, so unused indexes, you have to analyze database queries, you have to plan database sizing, you have to look at the configuration to get the consistent performance. And there is a wide range of database monitoring tools available to identify, fix missing indexes, optimize the data. In Java code profiling, I told you, right? This is a very big subject where you are going to talk about high method call counts, slowest methods, CPU intensive methods. You're going to look for slow database queries, excessive wait time, methods with network activity, methods generating high CPU, methods with disk activity. All these things are basically done at the code level. Application code, application server bottlenecks, again, application server bottlenecks. You have to do something called JVM monitoring. I'm going to share you the doc. JVM monitoring, you have to work on so many things. I mean, when I say monitoring rights, when coming to the monitoring, you always have 3 levels of monitoring. Okay, level 1 is request level monitoring. Someone asked me how to troubleshoot the problem. When I say request level, rate of incoming requests, rate of transactions processed, system resources information for the requests processed is what I'm going to monitor there. Okay. When I say level 2 monitoring, I'm doing component level. When I say component level, this is where actually the problem determination is going to happen. When I say problem determination, here you're going to monitor EJBs, you're going to monitor servlets, you're going to monitor JSPs, DNS, CDN, load balancer. You are going in specific with the component that is part of your environment in the underlying infrastructure. Okay, and the level 2 is, what is level 2? Level 3. Level 3 is method level. When I say method level, right? Method level, which method level, reason for deadlocks, problematic code. This is called tracing. Don't ask me what is tracing. Okay, tracing, you can add methods, trace information for problem determination, and you can increase some of the few things that I did from my JVM practices. I'm going to tell you. You can increase web container max keep alias. You can increase thread pool. You can increase database connection pool. You can increase minimum XMS, initial heap size, XMX, maximum heap size. You can disable explicit GC. You can also stop GC happening explicitly for increased response times. And there is one specific thing called precompile JSPs and ASPs. So whenever a page is developed, active server page is in ASP.NET, JSP is Java server pages for Java applications. Whenever a page is ready, you need to precompile them in the IDE to see how resources are utilizing that execution of that JSP or ASP and how much time they are taking. So this pre-compiling is going to help you to shorten the time. I mean, you can optimize that JSP or ASP that is developed at the very early stages of development. They can directly optimize it there itself. If you don't get to know the time that it is going to take of the JSP or ASP, it is going to give you increased response times. Okay, if you have too many short-living objects, you can know that by pre-compiling. You can know that by doing some code profiling directly by the IDE. Okay, you can identify top methods, top objects, hot methods by count. You can see the average heap size. You can compare the average heap size. You can compare the throughput, and you can see the requests. What value is increasing with what, and you can do that. In the last one point of the session, what I want to highlight, I want to tell you is, I want to tell you about the troubleshooting. When I say troubleshooting, many of the people come and say that we don't have access to the databases. We don't have access to the actual pre-prod environments. We don't have access to the monitoring tools. Then how are you analyzing or troubleshooting the problem that you're seeing is the question here. You know the importance of logs when you try to work on any application problem, right? .NET application, Java application, troubleshooting, debugging. You have to analyze the logs, okay, using various tools. Example, you have Logly, which is a very good SolarWinds Logly. We are actually covering that in this course content. Logs play a very key role in root cause analysis. If your application has a problem, right, logs can directly identify the cause and it will help you to find a solution. The logs contain important troubleshooting data, including the warning messages, informational messages, error messages, stack traces, and sometimes memory dumps. So these logs will directly provide complete insights on trends on your application behavior. And how to analyze the logs is the question again here. Manually reading the logs is okay for small applications, but large applications can generate thousands of events per second. You cannot read it manually. Okay, so for that, what you have to do is you have to gather the information about the problem, which means uh, you have to collect diagnostics data that might be relevant to the problem, take logs, take stack traces and bug reports from the functional team. What is it? Gather information about the problem. This is the troubleshooting actually. Okay, which means you are collecting all the information. Please don't mind, I'm going to close the session in another 5 minutes. I know it would be difficult to understand all these things, but as this is a technical concept, this is something which you commonly face in all the assignments in day-to-day activities. So when coming to troubleshooting, right, I'll also write it here because I will upload this video. Troubleshooting and debugging. When I say gather information about the problem, collect diagnostics data, take the help of APM, look at the metrics, look for the behavioral patterns, the trends of graphical representation, collect all the diagnostic data which is relevant to the problem, take the help of logs. Logs cannot be, you cannot read them manually. You need to take the help of log analyzers. You need to stream your logs in a tool like SolarWinds Logly. It is going to give you the complete information. Take the help of stack traces, take the help of bug reports from the functional team to identify the problem. Then the second thing is you are identifying the cause. When I say identifying the cause, you have to use the details of your diagnostics data to find out where and why the problem has occurred. Okay, you can repeat the user actions manually, then take the log, search logs for relevant events, use debugging tools to locate the problem in your code. Okay, so and the last one is you have to find and implement a permanent solution. When I say permanent solution, right? I'm sorry, you have to create a fix not only that is going to resolve your problem, but by incorporating that solution, it should not bring new performance problems. It should not impact the new other existing functionalities which are already working with acceptable performance, and it should permanently fix the problem. My final question, answer to all of you is avoid dirty and quick fixes just for the sake of release that is happening today night or tomorrow night. That is going to bring up so many escalations very soon. So you need to find and implement a permanent solution, which is not only improving the performance or giving the desired performance is a secondary thing. When you're incorporating a fix like that, it should not create new performance problems because you are already running out of time. So you have to resolve exceptions. You have to understand the stack traces because when you use Logly, I'm using Logly at this point of time. So when you give the status codes, it's going to give you, there is something called exception.stacktrace field. It's going to tell you where the problem occurs on which line. And you can see the failed transactions. You can see the HTTP status codes. You can, you can trace the transactions. All these things are quite common. Example, monitoring and debugging on Azure. Microsoft Azure is a complete cloud computing environment, right, for running applications, database servers, virtual servers, other assets. Using Azure Monitor, you can collect, analyze logs, metrics, other telemetry data, which can effectively monitor everything that you need. And it can also help us to troubleshoot cloud resources. And Azure is having, AWS is having, GCP is having so many several solutions for searching and analyzing this data, including application insights metrics, and they have their own inbuilt log analytics for logs. For more advanced analysis, what we are doing is we are streaming our logs to a service like Logly, which is from SolarWinds. Okay, so that's all for today. I know this is so short, but this is something that will be a common technical session which is going to help many of the fellow performance engineers right from 1 year to 10 years, 15 years. So that's all for today. Thank you so much. Thanks for your time, and it's so nice of you and nice talking to you. Thank you so much.